Alright, so this is angles of triangles notes. Second set of notes we're going to do in Unit 4, congruent triangles. I can tell you this starting off today, this stuff is algebra heavy. We're going to solve some equations. That's why it's a good thing that we're going back in our bell ringers and practicing solving equations. So some of y'all need it. Alright, so angles of triangles notes. The first thing you're going to learn is the triangle angle sum theorem. Most of y'all already know this, you just ain't never seen it written in words like this before. The triangle angle sum theorem says the sum of the measures of the angles of a triangle is 180 degrees. That's easy. So it's showing y'all to the side what they're saying. The measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. If you know that, then you can write an equation to solve for missing angles. And I'm going to mark these angles too. So angle A, angle B, all these angles too look different. So I'm going to mark them all differently. Yeah, so we're going to apply that theorem at some point. The other theorem you're going to learn. In the geometry, we learn a lot of what we call theorems and postulates. They're just things that can be proven to be true, so we accept them as truth, kind of thing. But another theorem that you're going to learn right now is exterior angle theorem. So this theorem says an exterior angle is formed by extending any one side of a triangle. So you got a triangle here. Let me zoom in. You got a triangle here, and then they extended this side right here and kind of created a line at the bottom going out infinitely. What happens is you have your three angles inside here, here, and then this angle here. But then by extending on this side, you create an angle on the outside. This angle 1. This theorem says the measure of angle 1, the one on the outside. Well, let me read this first. I'm sorry. An exterior angle is always equal to the sum of the two non-adjacent interior angles. Non-adjacent. Key word there. And y'all should remember what adjacent was. So when you hear non-adjacent, think opposite of that. Remember, adjacent was two angles sitting side by side. So they're saying angle 1 and this angle right here are side by side angles. These are adjacent angles. They're saying the two non-adjacent angles on the interior are equal to the sum of whatever the angle 1 is. So if I add these two angles on the inside together, I would get whatever angle 1 is on the outside. That's this theorem. So to write it down, it'll be measure of angle 1 is equal to measure of angle 2 plus the measure of angle 3. And I'm going to show you why that theorem is true later on. Let's go down and do some problems first. So the stuff we're doing today, we either writing our equation like this, triangle angle sum based on what they give us, or we writing based on exterior angle theorem. 1 and 2 are straightforward. It says find the missing angles. Well, find all missing angles. On number 1, they don't want us to find the missing angle, angle 1. And so triangle angle sum, like I said up here, says measure of angle A plus B plus C equals 180. Well, they're using numbers this time instead of what you call it. So to find angle 1, what I'm going to say measure of angle 1 plus 24 plus 37, my other two angles, equals 180. And then I solve. Oh yeah, you can use your phone or whatever. We're gonna need calculators today though. Our numbers are gonna be big. You add those together, you should get 61. So measure of angle 1 plus 61 equals 180. Subtract 61. Say it again. 119. Okay. Yeah. So when I subtract 61, I get the measure of angle 1 as 119 degrees. So that's triangle angle sum, using that one. The next one, just based on the way it's drawn, I can tell I'm going to have to use exterior angle theorem, because they got an exterior angle here, and then they got two what they call non-adjacent interior angles, or they also call these remote interior angles. They're not adjacent to this one, but they're interior angles. So the theorem says, and it's right above here, that angle 1, or this exterior angle, it may not always be numbered angle 1. This exterior angle should be equal to these two interior angles that are not adjacent to it. So using that concept, I'm going to write a equation to solve. So I'm going to say measure of angle 1 equals 76 plus 52. And then, yeah, just add together. Measure of angle 1 equals 128. So 128 degrees. Of course, that's easy. We always start you out with numbers. Numbers are always easy to do. The goal is to get where we're down here at the bottom, where you have to write equations for yourself and then solve. But the equations are no different. It's just now that you got expressions instead of numbers. The concept is still the same. So down here I'm solving for x. Actually, I'm solving for x. If you look down here, I'm solving for x, then I'm going to solve for a measure of angle D, then I'm going to solve for a measure of angle E, then I'm going to solve for the measure of angle F. So once I find x, I need to plug back in all three of my angles and get the value of the actual angles. Alright. Go ahead, Jalen. Who? We won't know until we solve. But I don't think so, no. Uh-huh. I'm listening. You can't be done. Girl, you ain't even finished writing the equation. I have no equal sign. Oh my God. And once I start writing the equation, I don't use those parentheses anymore. And those are just there in the problem. You don't need to separate all your stuff with parentheses, because some of y'all gonna think y'all should start multiplying when y'all shouldn't. After that, though, since there's so many variables and terms, I will starting out. Let's box some terms. So I got 5x plus 9x plus 11x. 25x. And then I got negative 2 plus 3 minus 21. Negative what? Equals 180. And then I'm solving. Thank you. I'm at 25. Yeah. Cancels. X equals, y'all say 8. Alright, so x equals 8. And after that, we need to find the measure of angle D, measure of angle E, measure of angle F. D first. 5 times 8 plus whatever. I mean minus 2. Excuse me, I'm saying the wrong thing. I heard 2 different numbers. Hold on, G. 5 times 8 is 40, ain't it? Minus 2? Lord have mercy. 38 degrees. That's angle D. And so E would have been 9 times 8, which is 72, plus 3, 75 degrees. And then F, let me say 11 times 8, 88, minus 21, 67. 67 degrees. And that answers your question, Jalen. E and F are not congruent. I say sometimes they look close just on, the numbers aren't too far off. Moving on. Number 4. This is exterior angle theorem. Devin, what equation would I write to solve for x? You gotta talk louder. I feel like your heart not in it today, man. I'm gonna come back to you. Jasavion. 18x minus 15 equals 13x minus 11 plus 4x plus 1. So on the left side, that expression is by itself. On the right side, we can combine some terms. On the right side, you got 13x plus 4x, 17x. And then you got negative 11 plus 1. Should get negative 10. And now we solving. I'm so happy we're doing equations and bell ringers. Y'all need it. Lucas, what you gonna move first? We just did this in bell ringers. You could, but I wouldn't. He said he gonna move 18x, but I wouldn't. You could. Move to 17. As soon as you move that 18x, you're gonna get a negative variable. And I don't want y'all dealing with those if y'all don't have to. What's 18x minus 17x, Lucas? X minus 15 equals negative 10. And what's the last thing you need to do, man? Add 15, add 15. Cancels. X equals what? X equals 5. Alright, so we got the value of x. Now we need to plug back in. We need to find our angles. This time, they made it a little harder for you, and that's what you need anyway. They said measure of angle CAB, measure of angle ABC, measure of angle DCB, measure of angle ACB. Good, but y'all should still know what all those angles are. Angle CAB, which expression is that? Alright, who talking to me? What is it, Billy? Good. CAB is this one, 13x minus 11. Y'all need to learn how to read angles. CAB, middle letter is where the angle actually is. Alright, so plug into that, tell me what you get. I ain't trying to solve these. 54 degrees for that angle. Okay. So CAB is 54. The next one is ABC. Which expression is that? 4x plus 1. So you said what now? Man, you were tripping. You subtracted 1. Next one is asking for a DCB. Which expression is that? That's 18x minus 15. Okay. What y'all got for that? And you plug in for this one, the exterior angle right here, you should get 75 degrees. And then they ask you for ACB also. Which expression is that? That was a trick question. ACB.
Oh, wait, no.
I hope everybody notices that ACB does not have an expression on it. Y'all with me? Let me mark that one for you. ACB is this one here. Wrong.
It's 105.
Thank you. How you get 105, man? Why you did that? Come on. Supplementary, because you see a straight line right there. I told y'all, everything I teach y'all comes back at certain points, man. Supplementary, because you got a straight line right here. So I know this angle on the outside is 75. This one has to be 180 minus 75. What you said was what, 105? Everything I show y'all comes back in here, man. And I'm even talk about that real quick. Let me see if I'm making a connection for some of y'all. There's a reason why this exterior angle theorem that we use work. The one that says that these two angles, these two remote interior or non-adjacent interior angles, add up to equal this angle on the outside. It's because of what you just did right there. So y'all all agree with me now that a triangle adds up to 180, right? So all these angles in here, these three, add up to 180 degrees. Well, they haven't been giving me this angle on this one. This angle right here, this 105, that was missing, right? So that 105 inside, that angle inside, adds up to 180 with these two angles. But that 105 also adds up to 180 with this exterior angle right here, yes? The 75 we had there. That's how they know that these two angles right here, if you add them together, would equal 75. Because this straight line right here adds up to 180, but also these three angles inside together add up to 180. I think I can connect some of that just for some of y'all. Some of y'all still gonna be confused, and that's okay. But I'm just trying to show you where the exterior angle theorem comes from. Does some of y'all catch that? If I get like a couple head nods, I'll be okay. The rest of y'all, I'll get on the back end. But that's where the exterior angle theorem comes from. They know that since this is a straight line that's formed by this exterior angle and this adjacent interior angle, that's a 180 relationship, but there's also a 180 relationship inside the triangle with these three angles. So this one's missing. There's a relationship, also kind of like a transitive relationship between these two and this one. These two added together will give you this exterior angle because of the 180 relationship. Alright. On Z back. Oh yeah, I forgot about this theorem. You know, isosceles and equilateral triangles on the back. Not hard either. So a closer look. This is isosceles and equilateral triangles. Y'all should remember this from yesterday. A little bit what they were at least. We're going to solve some equations based off of them. So the first theorem on the back for isosceles triangle theorem. It says if two sides of a triangle are congruent, which they are, then the angles opposite of those sides are congruent. So let me show you up here what they're talking about. And I kind of did this for yesterday, and I told you I was going to explain it to you again. They got this side AB is congruent and BC is congruent to each other. So I know this triangle is isosceles. they're saying that these two sides are congruent. The angles opposite of those two sides are congruent to each other too. And you should be able to see it too. That angle 2 and angle 3 are congruent. That's just a sight thing. You can see that. This is why I was telling you too that we call these base angles. In our isosceles triangle, we call these two angles base angles. That top one, only in our isosceles triangle, we call that a vertex angle. But these two down here we call base angles. They're congruent to each other. This one isn't. Alright. So, putting the theorem in words, says if, it's supposed to be an if, segment AB is congruent to segment BC, that means then angle A is congruent to angle C. And the converse to that is another theorem under here. It's the converse to the isosceles triangle theorem. It's just going in reverse. If they give you the two angles that's congruent, then you can assume the two sides opposite of those angles are congruent. So it's the reverse of that is saying, okay, if I tell you the two angles are congruent, then you can assume those two sides opposite of those angles are congruent. So it's just going to be this statement in reverse, really. So this statement is going to be if angle A is congruent to angle C, then segment AB will be congruent to segment BC. Yeah. That's all cute. Let's do some work. Of course, it always start out easy. We always start you out easy. Don't get bogged down on these easy ones. We'll never put these easy ones on the test, but they're good to start you out with. But I will let somebody impress me. We need to find the measure of angle J and the measure of angle K. Once it's find each variable or a value of each variable. Find each measure or a value of each variable. I need to read better. Number 5. Same two people. Miss Torres, number 5. What's the value of angle J? You gotta talk louder, I can't hear you. 68 degrees. I agree with you. Since the value of angle J is 68 degrees, do you know how you will find the value of angle K? I can't hear you. Still can't hear you. You gotta talk louder, Billy. That's not gonna give me angle K. Go ahead and save me on because I can't hear her no way. I agree with that. So I'm gonna write it out as an equation. You know I am. If you find a simple measure of angle K plus 68 equals 180 degrees. That's triangle angle sum. If I got 2 out of 3 angles of a triangle, I can always use triangle angle sum. So measure of angle K equals what you said. 68 plus 68 was 136. And then I need to subtract 136. You gonna say that's what? 44. So 44 degrees. And K will be 44. Sliding on. Victoria. Number 6. How would you solve it? Good. On this one, you will get something like this. You should notice this is isosceles triangle. So you should know that this angle and this angle here are congruent. Now, I know this figure is turned upside down, but you should still be able to recognize what two angles are congruent. Like Victoria said, that being, and we talked about this the other day when we did that triangle on our other triangle on our notes. Since this angle is 106 degrees, I know these two angles are the same, and they got to be half of what's ever left over when I subtract this from 180. So like Victoria said, I mean, you can write an equation if you want, but you can just simply just do this one by 180 minus 106. You're going to get 74 degrees. Some of my kids stop there, though. You need to understand this is two angles here. You need to divide by 2. Divide that by 2, you're going to get 37. So my two angles will be 37 degrees. 37 here and 37 here. Moving on. Number 7. Based on what we talked about with isosceles triangles just now, Zach, what equation would you write for number 7? Hold on. Go ahead, Zach. You're going to have to talk louder than that. You know that. I can come back to you. I'm going to come back to you. Emra, what equation are you writing for number 7? Why you decided to do that? I'm asking. I want to know. Because other kids are going to decide to do that too. You just said because they're congruent. Because they're congruent, you're going to set them equal to 180? I told y'all, just use your brains, man. Just use some common sense. You said the right thing, but you just decided to go 180. What's the main reason I can't write a 180 equation on this one? I don't have a third angle up here, right? I don't have anything there. So how am I going to use a 180 equation anyway? I don't want to do that at all. But you said the right thing, though. You said these two are congruent. You're telling yourself how to write the equation. If two things are congruent, you can always do what with them? Set them equal to each other. Y'all gonna make me solve everything? I ain't gonna solve this one. You solve it for yourself. I don't want to solve it. Solve it for yourself. I solve it. Emma, this was your problem. Tell them the answer. Y'all probably didn't hear me say x equals 8. That's what y'all should have got. The next one. On this one, they give me two expressions on the outside of my figure. That's the only thing I need some of y'all to recognize. The last problem, those expressions were for the angles here. They had arrows pointing to the two angles they wanted. This problem, these expressions on the outside, these are for the sides. Don't make no difference. Still solve for x. But on this one, they're showing you these two angles are congruent. So if these two angles are congruent, the converse of the isosceles triangle theorem says that these two opposite sides here and here have to be congruent. That's the case. Devin, what equation you writing? I haven't given up on you yet, man. Devin, you killing my video here, man. What equation are you writing? You can't be that out of it. Rodriguez. Rodriguez, go ahead. Thank you. Solve it. I solve it. I don't care. Okay. Let me know what you get, Rodriguez. One more time? Yeah. Cool. Moving on, children. Last thing, equilateral triangles. We're blasting right through. Alright, equilateral triangle. Let me zoom out a little bit. Equilateral triangles. A triangle is equilateral if and only if it is equal angular. So, statements down here. First one says, if the measure of angle A is equal to the measure of angle B and the measure of angle C, then segment AB is congruent to segment BC, which is also congruent to segment CA. And then they got the converse under that one too. Then they go back and say if AB is equal to BC, which is equal to AC, then the measure of angle A is congruent to the measure of angle B, which is congruent to the measure of angle C. Equilateral is the easiest one to deal with. Out to the side here. On your actual equilateral triangle, that means angle A is congruent to angle B, congruent to angle C. And then AB is congruent to BC, which is congruent to CA. Jorge, I'm going to throw you a softball here. Says find each missing measure and the value of each variable. Jorge, on number 9. got triangle ABC. They didn't give you all the information on that triangle, but they gave you enough. We all know a triangle adds up to 180 degrees. If angle A is 60 degrees, angle B is 60 degrees, what's angle C? 60 degrees, right? Alright. Kind of answered that one for you. I wasn't supposed to. But Jorge, do these two for me. What is the length of BC? Say it again. No. I'm asking you what's the length of segment BC? Okay. Tim cannot answer all the questions, neither can Jasavion. Yes. Yes. Louder. The length of BC would be 9 feet. Might as well finish this off. What's the length of AC? I'm still asking you. What's the length of AC? Yeah, 9 feet. I told y'all, common sense stuff. I'm gonna help some of y'all develop it though. All these sides are congruent. This ain't no trick question. Guess I'm about to blow some of y'all minds on this one. Alright, next one. It says note. Triangle PQR is an equilateral. That's the case, you can go ahead and mark that on your triangle. How do you mark that? With side markings. Show that all these sides are congruent, please. I'm gonna see what some of y'all hear that. I get one person every year that's gonna give me this answer. So we gotta solve for X and Y. Nope, you can't answer this, Jalen. We're gonna solve for X and Y. I always like to solve for my variables in order. We're gonna solve for X first. Notice where X is. They want us to solve for X. Let me shop this around a little bit, just say, you know. What equation would you write to solve for X? Knowing what you know about this triangle. Give me a sec. Let me shop it out a little bit. See if any new hands pop up. Alright. I'll go ahead and let Jasavion answer. Go ahead, sir. Good. Thank you, sir. You're shining today, son. Yeah. To solve for X, alright, 7X, let me get my purple pen to work. 7X minus 3 equals 60 degrees. Y'all should all know why. We call this an equilateral triangle, yes? All these angles have to be 60 degrees. Told y'all it's a common sense subject. If that's the case, I know that angle equals 60 degrees, so I can write an equation equal to 60. Solve for X. Y'all know I'm not about to do that. Save some room too, because we gotta solve for Y. Saving on X equals what?
9.
Thank you. Zach. I'm writing that down for y'all. Y'all need to solve it though. X equals 9. We need to solve for y next. You solved for y already? What equation you wrote? Talk louder. I like what you're saying, but talk louder. Okay, so he said he did 14y minus 59 equals 9y plus 1. So let me talk to y'all real quick. I thought Zach was going to mess it up. Every year I always catch the kid that's going to do it wrong, but this year I got the right kid. Listen, on this one, and Zach, thank you, you did it perfectly, man. On this one, they give you an expression on all three of your sides. All three sides are congruent. I don't need all three sides to solve for y. If they all three equal, I only need 2 to write an equation. And understand that these are sides too. Last year I had kids adding all three sides up and setting them to 180. You can't set sides equal to a degrees, first of all. That's the main thing I need to understand. Sides and angles are different. Sides you don't set equal to no degrees. You don't set a side equal to any kind of degrees. And then the other thing is, you don't need all three sides. I'm glad you noticed that, Zach. Most kids don't off bat until I teach it to them. You don't need all three sides to solve this. And you can pick any 2 sides you want. I'm going to show you that any 2 sides are going to work. Y'all probably solving that one right now, but any 2 sides you pick will work. And honestly, Zach picked the sides I wouldn't have picked. For me, I always look for the smallest numbers. So I would have picked 9y plus 1, and I would have picked 11y minus 23. I showed when to use the 59. But that's just me. But you pick any 2 sides you want. Y'all pick those, but he picked those 2 sides. What y'all got when you solve for y? Anybody saw that yet? Yeah, y'all should have got y equals 12 when y'all saw this, right? What I'm telling you is you could have picked any 2 sides you wanted. I'm going to pick my own sides. I'm going to do 9y plus 1 equals 11y minus 23. I'm doing it in red just to show you I'm going to get the same answer. Subtract 9y. One equals, what's that? 2y minus 23. Then I would have added 23. I got 24 equals 2y. Then divide by 2. Obviously, I'm going to get 12. I'm still get y equals 12. Either way you go about it. Pick 2 congruent sides, roll with it. Use some common sense, kids. Alright. I was nice to y'all today, too. There was a practice and a home learning sheet that went with this thing. I only printed out the home learning sheet. I said it's Friday. I don't want to put too much pressure on you. And you got to submit the home learning sheet anyway, so.